In this illustration, we intend to simulate a steel plate shear wall with two rectangular openings under the cyclic loading in the Abaqus software. In this picture, you can observe the laboratory model, and in this picture, the model having been simulated in the Abaqus software can be observed. In this problem, a cyclic loading is applied to the steel shear wall, and then the hysteresis diagram of the model will be drawn. In this picture, the hysteresis diagram of the model obtained from the Abaqus software have been compared with the laboratory results. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Experimental Investigation on Stiffened Steel Plate Shear Walls with Two Rectangular Openings. In the next step, I will click on Create Part in order to create the geometric shape of the top beam. I will select 3D, Deformable, Shell, and Extrusion, enter approximate size equal to 1000, and continue. Here you can observe the cross-section of the top beam, in which the length of the flange is equal to 140 millimeters and the length of the web is equal to 250 millimeters. The length of the top beam is equal to 1410 millimeters. I will click on Create Part. I intend to create geometric shape of column. Here, the cross-section of the column can be observed. The length of the flange is equal to 140 millimeters and the length of the web is 60 millimeters. Done. The length of the column is equal to 1210 millimeters. Here, I will select all the parts except the bottom beam. Done. First, I'll select this point, then this one, and OK. In the next step, I will select all the parts except the bottom beam again and move them as much as 335 millimeters rightwards. Here, in this table, the properties of different parts have been defined. First, I will define the properties of plate with a thickness of 2 millimeters. I will click on General menu, select Density. The density is equal to 7.8 multiplied by 10 to the power of negative 9. After that, I will click on Mechanical menu, select Elasticity and Elastic. Young modulus is equal to 206,000 megapascal. The Poisson ratio is equal to 0.3. In the next step, I will click on Mechanical menu, select Plasticity and Plastic. Yield stress is equal to 189.5 megapascal. The thickness of infill steel plate is 2 millimeters in this problem. I will click on Create Section. I intend to define the plate section. Here, I will select Shell and Homogeneous, Continue. Here, I will select the material for 2 millimeters plate. The thickness of plate is equal to 2 millimeters and OK. Here, I will click on Assign Section and select Plate. Done and OK. Click on Seed Part. Enter approximate global size equal to 20 millimeters. Click on Assign Mesh Control. Select the whole of the model. Done. Here select Medial Axis. OK. Then click on Mesh Part and Yes. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abaqus software, in which the horizontal axis is displacement and the vertical axis is force. I will click on Create XY Data, select ODB Field Output and continue. Unique Nodal, then select RF3, after that select U3. Here I will select Set2, that is related to the place of loading, and click on Save. In the next step, I'll click on Create XY Data, select Operate on XY Data, continue. Here I will select all reaction forces. Select the sum, then click on Add to Expression and then Save As. In this manner, all reaction forces will be added up together. In the next step, I'll select Combine. First, I'll select U3, then Force and click on Save As. Here, you observe the hysteresis diagram of the model. I will transfer the diagram to the Excel software. The first column is displacement, the unit of which is millimeter. The second column is force, the unit of which is Newton. Here, the diagram having been drawn with yellow color is the one having been obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software have a good conformity with those mentioned in the article, indicating that the problem has been simulated correctly in the Abaqus software. Actually, the results obtained from the Abaqus software are concordant with the laboratory results.